Assalamu alaikum. Hope all of you are fine. Welcome to my channel, Mathematics Lectures with Kashif Saleem. So today's lesson is about matrices. So we will discuss today matrices, its definition, order of the matrix, and on the basis of the order of the matrices, we will define some of its types. But first question which comes in our mind is why we need matrices. So matrices are used much more in daily life than people would have thought. In fact, it is in front of us every day when we are going to school, when we are going to work at the university and even at home. So the reason why matrices are so important because it provides us better representation and visualization of raw data. That is why it is widely used in circuit designing, in engineering, and in economics, and most importantly in computer programming and in computer graphics. So if you have seen some of the software like Adobe Photoshop, which uses matrices to render images using linear transformations, so it's all about matrices. So let's get started. First, we will define matrix. So any rectangular arrangement of data is known as matrix. Basically, it is the elements arranged in a rows or in columns is known as matrix. So we can say it equivalently. Now, what is the representation? So if you have a square bracket, this is A11, A12, A13, and so on. So A21, A22, A23, and A31, and A32, and this is A33. So the elements arranged in rows or in columns is known as matrix. So it is denoted by a capital letter A. For example, this is matrix A. Now there are 3 rows and 3 columns. So this is a 3 by 3 matrix. Similarly, we can define a matrix A11, sorry, A11, A12, A13, up to so on. And if there are n columns, so this is 1n. So now A21, second row, first column, second row, second column, second row, third column, and this is the nth column, A2n. Similarly, if there are m rows, so this is m1, this is am2, this is am3, and so on. This is amn. So this is the m by n matrix, and this is a 3 by 3 matrix. Now we define order of the matrix. It is it is the number of rows and columns in the matrix. So there are three rows and three columns, so we say that it is a 3 by 3 matrix. So there are three rows and three columns, so it is a 3 by 3 matrix. Now consider some other examples also. If I say 1, 2, and 3, so this is 1 by 3 matrix. So it has only one row, it has only one row and three columns. This is first column, this is second column, and this is third column. So this is 1 by 3. Consider another example. 1, 2, 3, and 4. So it has first row, and this is the second column, so second row. This is first column, this is second column. So the order of the matrix is 2 by 2. Now consider another example. It has only one element, which is 2. So it has one row and one column. So it is a 1 by 1 matrix. Now we define some of the types of the matrices using order of the matrix. So first type is a square matrix. If the rows and columns are same, then matrix is known as square matrix. So this is known as square matrix. If the rows and columns are same, then the matrix is known as square matrix. So we have this matrix. So this is a 2 by 2 matrix. So it is a square matrix. This is a 3 by 3 matrix. This is a square matrix. So if rows and columns are same, then we say that matrix is a square matrix. So this is a very important class of matrices. So we will consider it again, inshallah, in a good detail. Now consider another type, a raw matrix. If a matrix has only one row then it is said to be a square matrix. Sorry, raw matrix. The raw matrix. So if we define it by only 1, 2, and 3, 2, 0, 3, these matrices have only one row, so it is a raw matrix. So these are all the examples of the raw matrix. Now consider another type. So next type is column matrix. If it has only one column then it is said to be a column matrix. So what are the example? Now, if we have only one column in a matrix, then it is said to be a column matrix. So 2, 3, and 4. So we say that this is a column matrix. This is also a column matrix, 0 and 1. These column matrices represents basically a vector, which is very important when we use transformation in some of the real life problems. So now define another matrix, a diagonal matrix. Matrix to be a diagonal matrix if it has only only non-zero diagonal elements. So if I write here, two zero zero three sorry 4, all the other elements are 0. So this is a diagonal matrix because all the elements are 0 except the diagonal elements. So now we define a new matrix using a diagonal matrix, which is a scalar matrix. So a scalar matrix is a matrix in which all the elements in the diagonal are same and all the other elements are 0. Then the square matrix is also known as a scalar matrix. So it is a subset of a diagonal matrix. So what is the definition? So definition is, so if in a square matrix, all the elements are same in a principal diagonal and all the other elements are 0, then it is said to be a scalar matrix. So first element, let's suppose elements are k, diagonal elements are k. So this is k 0 0, this is 0 k 0, and this is 0 0 k. So this is known as scalar matrix. So diagonal matrix, square matrix is the biggest subset, is a superset of diagonal matrix, and diagonal matrix is a superset of scalar matrix. And scalar matrix is a superset of basically identity matrix. So what is identity matrix? Identity matrix, if you take common from this matrix, so this k is common. Now take 1 0 0 0 1 0 and this is 0, 0, 1. So this matrix is called identity matrix. So this is k equal to I. So what is identity matrix? Identity matrix is a scalar matrix in which all the diagonal elements have the same value, which is equal to 1. So if k is equal to 1, then a scalar matrix is known as identity matrix. Now next move on to the other type, which is a null matrix. So what is null matrix? Null matrix is a matrix in which all the elements are 0. This is 0, this is 0, this is 0, and so I write it 3 by 3 matrix. So this is known as O3. Similarly, we can define I2 and I3. So what does it mean? I2 means a 3 by 3 matrix, a 2 by 2 matrix, and I3 means a 3 by 3 matrix. So this is I3, and if we write I2, what is I2? I2 is equal to 1, 0, 0, and 1.